Uh, yeah. Uh, yeah. Uh.
Most people are faced with the confusion that when a force or when a force is facing upward, we say it is positive, and when it is facing downward, we say it is negative. When it is facing the left, we say it is negative, and when it's facing the right, we say it is positive. Why some disagree and they say no, when the force is facing upward, it is negative, and when it's facing downward, it is positive. When it's facing the left, it is negative, and when it's facing the right, it is what positive. If you say the first scenario is correct, you are correct. If you say the second scenario is correct, you're also correct. Now, good day everyone. My name is Graphics. We have what we call mechanical engineering science, which is called mechanics, right? And it is divided into two. One of the aspects is called statics, another aspect is called dynamics. Now, when you talk about statics, statics support the first that says that forces facing upward, right, is positive, forces facing downward is negative, forces facing the left is negative, forces facing the right is positive. While dynamics support force facing upward is negative, while the force facing downward is positive, the one facing the right is positive, and the one facing the left is negative. And this makes sense because when you talk about motion, especially when you talk about motion due to gravity, we say that motion under gravity is what? Is positive when the object is falling, while motion under gravity, the force when it is facing upward, when the ball is thrown upward, it is what? Negative because it is opposing gravitational pull. But I'm not going to that aspect now. What I'll be focusing on this topic will be statics. Now, if you recall, we say statics is dealing with what? Forces acting on the rigid body, right? Now, what are these forces? We say force is anything that can change, right? Or tends to change the position of the body at rest or at uniform motion, right? So a force can alter and a force might not alter. It depends on the reaction force, right? So it's not every force that you apply that can really bring about a change. The force can try to change or it can change, right? If you remember in your mathematics, when we want to plot our graphs, we have what is called the y-axis and we have what is called the x-axis, right? Any force that is parallel to the x-axis, when I mean parallel, I mean lying down this way, either it is facing the right or it is facing the left. You say it is f of x, you call it f of x, right? That would mean force acting along x-axis, or you call it horizontal component, right? So when I say horizontal component, I mean either the force is facing right or it is facing left, right? It depending on what is given. Now, if the force is parallel to the y-axis, when I mean parallel to the y-axis, I mean the vertical force. Either it is facing up or facing down, as long as it's standing parallel to the y-axis. When you say parallel, it means they will not meet at any point in infinity. You call this kind of force f of y, or you call them vertical component, right? So when you hear the word vertical component, it can be upward force or downward force. When you hear horizontal component, it can be forces acting towards the left or forces acting towards the right. Is that taken? Now let's move forward. Right? Let's assume we have a ball, right? And two different forces are pulling it in opposite direction. Let's say those force is F1 and the other force is what? Is F2, right? Now, since they are pulling in opposite direction, we say that the net force along the x-axis, because you see the forces, when you see any force lying down this way, you see they're acting along x-axis, and you call them f of x, or you call them horizontal component. So we say the net force, we'll call it F net, or we put the summation of what? Of f of x along the horizontal axis is equals to F1 plus what? F2. Now let's now assume that F1 is giving us what? As 3 Newton. And the force going towards the right is F1, and the one going towards the left is what? F2. I would say we're assuming F1 is giving us what? 3 Newton. And F2 is giving us what? As 4 Newton. So we'll now say that the net force will now be giving us F1 plus F2. So what is F1? Due to the fact that the force is facing the right, we say that what we'll be having positive 3 plus F2. Due to the fact that the force is facing towards the left, we say that what is negative what? 4 Newton, right? Now this is what we have. So by the time you say your 3 plus times minus give you minus, minus 4, we're having what? Negative 1 Newton. Now, that what we'll be having? Negative what? Negative 1 Newton. That means the force will be put towards the left, since the force is what? Is negative, right? Now, let's assume again that we still have the same ball. We're still under case 1. We still have the same ball, right? And two forces are pulling them in the same direction. Let's say what? Still the F1 and what? And what? And F2, right? So the summation of the forces along x-axis, or you say the net force along x-axis, is giving us F1 plus F2. And we say our F1 is giving us 3 Newton, our F2 is giving us what? 4 Newton. So since they are facing the right, both of them are positive. So we'll now say that what? Our F1 is 3 plus our F2 is what? Is 4. So the net force will give us what? 7 Newton towards the right, right? Now let's talk about what about the force is acting vertically, right? We have vertical force, and we also have horizontal force. What we did earlier is horizontal. What we are doing now is vertical. Your vertical force can either be upward or downward, while your horizontal force can either be left or right. So we are dealing with the vertical force now. So we said that the upward force is F1 and the downward force is what? Is F2. Now we want to look at the net force. That means the net force here means the summation of F of y. That means the force acting along y-axis, right? The addition of the forces, or the summation of the forces acting along y-axis, right? So we'll now say that what? My F1 plus F2, right? So what is the F1? F1, we say it is 3 Newton and it's facing upward. So since facing upward in statics, upward force is positive. So it will be 3 plus F2. Where's F2? F2 is 4 Newton facing downward, right? So it will be minus 4 since it is facing downward. The downward sign denotes that what? It is negative. So it will be 3 minus what? Minus 4. And we'll be having what? Minus 1 Newton. Is that taken? So this is upward force, this is vertical force, and that is horizontal force. Now, let's take another instance. What about case 2? What about when the force is acting perpendicular to each other? The force are at right angle to each other. Let's say the one we have F1 and we have what? F2, right? So we are assuming that the vertical one is F1 and the horizontal one is F2, but what? They are acting at 90 degrees to each other. So in this case, if you can go back to your Pythagoras theorem, we realize that if we want to look for the net force will be the force that will be connecting these two forces, right? So let's say our net force will be our F net. Is that taken now? So this is forming what? A triangle. It is forming what is called what? A triangle. A right angle triangle. So we want to calculate the net force. So we'll be applying what is called our Pythagoras theorem, right? So we say that the Pythagoras theorem is giving us the hypotenuse square plus the hypotenuse square is equals to what? The adjacent square plus the opposite square. That is my Pythagoras rule. Now, what is the hypotenuse here? Hypotenuse is what? Our F net square. The net force square equals to our adjacent here is the F2. So we have what is called F2 square, right? Plus the vertical, that is the opposite. Why am I calling opposite? Because our angle here, let's call here to be what? Alpha, or we'll call it to be what? Theta. It's given as what? Opposite square, which is what? F1 square. Now we assume that from the beginning we say, let's say our F1, if I want to move forward, so we say that my net force, right, will now give me, if this square come to this side, becomes square root. The square root of what? F2 square plus F1 square. And it makes sense. Whenever you're calculating for the net force, right, of two forces that are perpendicular to each other, we make use of this. Is that taken now? So we'll call this the resultant force. In terms of this, we'll call this what? The resultant force. Because you cannot see the net force along the horizontal axis, neither can you see the net force along the y-axis. You say what? Resultant force. So you're bringing all the forces together. So this will now take us to a formula that says that before we even go there, let's now assume, let's just take notes of this. Let's call this to be my equation 1, right? We're coming back to this. Now, from here, if you are, we'll say our F2 here, we have the square root. Our F net is equal to the square root of, what is the F2? F2 is 4 square, right? Plus F1, F1 is given as what? 3 square. And this will give us the square root of what? 16 plus 9. And that will give us square root of 25. And that will give us what? 5 Newton, right? Because we know force is measured, the unit for force is in Newton. So we have 5 Newton here. Now, if you look at this formula here that says that F net is equals to F2 square plus F1 square, it makes sense because we can call my F net to be R equals to, we can call the F2 should be the forces acting along x-axis. You can say what? It will give us my Fx all squared. Fx means forces acting along x-axis all squared, right? So we can call F2 as Fx because it's acting along x-axis, plus F1 is given as Fy, F1, Fy all squared. So we can write it this way also, because we only have two forces, right? What about there are more than one force? So what we'll be using there will now be our resultant force will now give me, instead of writing the Fy, Fx, you write the summation of what? Of Fx all square plus the summation of what? Fy all square. That is when you have more than one force acting along x-axis and more than one force acting along y-axis. So we use summation. But if they are just single, you use the f of x and what? The f of y, right? So you should not forget about this formula. It is very important when you're about to calculate the resultant force. And when you are asked, what is the resultant force? You say the resultant force is a single force that can replace two or more forces and still produce the same effect as those force, right? So our F net in terms of perpendicular force is also called our resultant force, right? Now we move forward. Now this is resultant force. Now at what angle? Because when I told you there's a single force that is connecting F1 and F2, is acting at an angle, and that angle is given as what? As theta, right? Now if you want to calculate for the angle, you're going to be using your TOA from the word SOHCAHTOA. And the TOA means that T stands for tan is equals to the opposite all over what? The adjacent. So we say tan theta will now be equals to, what is the opposite? Opposite is the side that the angle faces, which is F1, to be F1 all over adjacent, right? That is what? Adjacent is what? F2 along the x-axis, right? So we have tan theta is equals to what? F1 over F2. We can also be written as what? Tan theta is equals to what? Summation of f of y or we can say tan theta is equals to what? Fx, Fy, right? All over what? Fx. Or we can also say that what? The summation of what? Fy all over summation of what? Fx. That's my tan theta. So this is how you calculate for the angle at which the resultant force acts, right? So now, two important formula you need to know is the first one is the resultant force, right? Which is giving us this square root of summation of f of x all square plus summation of f of y all square. You should know this. And the other one is giving us tan theta is equals to summation of f of y all over summation of what? F of x. This is two important formula. So this is case 2. Case 3 is when this force is acting at an angle. Imagine you have a force acting at an angle theta, and to you're told to find the resultant force, right? Now, if you click on this link at the top right corner, it will tell you more about when the force is acting at an angle. So those kind of situation, we are going to what? Resolve the forces. So click on that link, this link I mean, that I posted up here to tell you more about resolution of force. And we say resolution of force is the resolving of forces into horizontal and vertical component, right? So when you go to that, click on that link, it will direct you to the page at which you understand more about resolution of forces, right? So if you have found this video helpful, please don't forget to click on the subscribe button. Thanks for watching.